Right now we're going to talk about scientific notation and why we need it. Scientists came up with scientific notation because they realized very quickly that they sometimes have to work with really, really big numbers. Take a look like this. This is a big number. And sometimes we have to work with some really, really small numbers. Why? Because, for example, when we talk about distance in space, things are really, really far apart. Really far apart, farther than multiple of our planets. Okay, so we have to sometimes measure things that are really, really big. At the same time, sometimes we have to use an electron microscope in order to look at things that are really small, like some bacteria. So we have to be precise with our measurements and accurate. And so in order to do that, scientists said we can't necessarily always use numbers like this to be able to use and to calculate with. We need to come up with another way to represent these numbers. And so they came up with scientific notation. So there's two kind of steps that you need to have with scientific notation. The first step is the first part is a number that has to be between the numbers 1 and 10. So the first number that we have, we want to make sure that we take the number that we already are using and convert it into a number that's going to be between 1 and 10. The second part says that we're going to make sure that this next is going to be to a power of 10. So we're going to have times 10 with an exponent on it. Okay, so let's take a look at an example. Okay, so here we go. We have 5,024. It's still a big number. So take a look. We want to have a number that's going to be between 1 and 10. So I'm going to need to move my decimal point that's originally right here, and I need to move it to a different spot so that my new number is between 1 and 10. Well, if we take a look at what we have that's already been seen, we see that the person who has done this one has placed the decimal point in between the numbers 5 and 0. So let's take a look. It is now 5.024. Is that a number that's between 1 and 10? Yeah, 5.024 is in between 1 and 10. Okay, so this is where we have placed our new decimal point. It originally was right here, and now we've moved it in between that 5 and 0. So then we multiplied it by the power of 10. But where did they get the 3 from? Well, originally our decimal point started here, and each of these unit holders, or I should say our number holders here, has a value of 10. So we're able to have 10 different things. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So each of those holds 10 units. So what we're going to do is we're moving it over a place of 10. 1, 2, 3. So that's where they got 3. The number of places that they moved the decimal. Okay? And so that's where they got to the power of 3. So this would be, in scientific notation, 5.024 times 10 to the third. Okay, so let's go on to the second one here. We have 0.000000843. My decimal point is already put right here. So just like before, we need to move our decimal point so that there's a place that's our new number will be between the numbers 1 and 10. So I take a look. And if we see in our answer over here, we've already put the decimal point between the 8 and the 4. Does that make sense? 8.43, is that between 1 and 10? Of course. So I'm going to put that right there, my decimal point right there. And again, we're going to count the places that we moved in order to get our decimal point to the new spot. So we go 1, 2, 3, 4, 5, 6. But wait, take a look. The number 6, but now it's a negative number. Okay, so let's take a bigger look at this. When I had a big number, 5,024, and when I define big, we're going to say any number over the number 1. So any number bigger than 1 is considered a big number. When that was a big number, we had a positive exponent. So big numbers have a positive exponent. When we had a small number, right, anything we're going to define small as less than 1, so in this case, we're going to say has a negative exponent. Okay? So when we have big numbers, positive exponent. When we have small numbers, we're going to represent it with a negative exponent. Okay, so let's keep that in mind for the problem that we originally had. So here we go. We have 45,600,000. Okay, where am I going to need to move my decimal point? Originally, my decimal point is right here, but I need a new spot so that my number is in between 1 and 10. So I'm looking, I'm going to put it, oh, I could put it between the 4 and the 5. Let's see, 4.56. Okay, let's take a look. Is that a number between 1 and 10? Yes. What if I tried putting it between the in between the 5 and the 6? So if I did 5.6, is that a number between 1 and 10? No. So again, we can only have one spot where the decimal point will be between 1 and 10. Okay, so this is going to be our new spot. That's where our decimal point is going to be. We need to move it over. So we're going to multiply this by a power of 10, as we said, and we'll move it over. 1, 2, 3, 4, 5, 6, 7. Okay, so it's going to be to 7. But before I can do that, was this a big number or a small number? It definitely was a big number. So my exponent is going to be a positive number. So we moved it over 7 spots. It's going to be a positive 7. So my answer would be 4.56 times 10 to the 7th. Okay, let's look at the next one. Same idea. We're going to put the decimal point in a place where the number is going to be between 1 and 10. Well, let's see. Can I put it in between the 2 and the 3? Let's take a look. So I'd have 902.31. Is that a number between 1 and 10? Definitely not. What if I put it in between the 9 and the 0? Let's take a look. 9.0231. 9.0231. Is that a number between 1 and 10? Yes. So we're going to multiply it by a power of 10. And since my decimal point's already given here, we're going to move it over. Let's see. 1, 2, 3. So that's where my new decimal point is going to go, right? Is this a big number or a small number at the beginning? Well, it's a number that was less than 1. So we said little or small numbers are going to have a negative exponent. So we moved it over 1, 2, 3. It's going to have a negative 3. So this will be 9.0231 times 10 to the negative third. Okay, we're going to try one more. What if we're given scientific notation and we want to go into regular numbers? Okay. Well, remember we said exponents that are positive, are they big numbers or small numbers? They're going to be a big number. So because it's positive, must be a big number. Okay, so it must be big. So what I'm going to do is I'm going to move my decimal point over so that it will be a bigger number. Well, if I move it over this way, it's going to make it a really small decimal. I want a bigger number. So I'm going to move it over this direction because it's going to be big. So we'll go over 1, 2. So this will be my new spot for my decimal point. So I'll write 613.2. And that's how you convert. So 613.2. Let's try it again for number 4. Okay, I look at my exponent. Is it a positive or negative? It's a negative. And remember we said if it's a negative, it must be small. So we need to make sure that our number is going to be a decimal point that's less than 1. So instead of going this way like we did last time, we're going to go in the opposite 6 way, in the direction of 6. Okay? So we have 4.586, right? I'm going to go over 6 places. 1. Oh no, but I have no more. We'll just keep going. 2, 3, 4, 5, 6. That's my endpoint. But I have all this space in between. Well, I'm going to fill that space with zeros. I like to think of it like a little egg carton. These little holders are where you're going to place your zeros. So place our zeros in all of them. And our end result will be 0.00000458 And that's how you do scientific notation, from converting from standard numbers to scientific notation and from scientific notation to standard numbers.